NEET Model Exam 2025 Physics. Answers from question number 31 to question number 36. Question number 31. A particle executes linear simple harmonic motion with an amplitude of 3 centimeter. When the particle is at 2 centimeter from the mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period is. So finally, we need to find out what is the time period formula. We need to find out what is the time period. So what is the condition is given? A particle executes a simple harmonic motion. And amplitude is given to be 3 centimeter. And the displacement from mean position is given to be 2 centimeter. Right? Now, also the condition is magnitude of velocity will be equal to magnitude of acceleration. I know the formula for velocity in a case of linear simple harmonic motion, that is nothing but omega into square root of a square minus x square, which is equal to magnitude of acceleration can be written as omega square into x. So omega get cancels. From there, I can find out omega, which is equal to root over a square minus x square. A is nothing but 3. So 9 minus 2 square is nothing but 4. Divided by x is nothing but 2, which is nothing but root over 5 by 2 radian per second. Now we need to find a time period t, which is equal to 2 pi by omega, where omega value is nothing but root 5 by 2, which is nothing but 4 by root 5 seconds. Then correct answer for this question number 31 is option C. Question number 32. Given below are two statements. Statement 1. A conductor has large number of free electrons moving with the thermal velocity, but in absence of electric field, external electric field, net current flowing through it is 0. Statement 1 is obviously right. Statement 2. Due to random motion of electron, net flow of charge through any cross section of the conductor is 0. So both the statements are correct. Now answer for question number 32 is nothing but option C. Question number 33. Which of the following transitions gives photon of maximum energy? Okay. Now, we know in an atom, there will be different states of energy level. And energy level in an hydrogen atom can be given by the formula, can be written as that is in an nth level, En, which is equal to minus 13.6 by n square electron volt, right? So if an electron is transiting from higher to lower, there will be emission of photon with certain energies. But from lower to higher, there is no possibility of emission of photon. So obviously option B and C get cancels. Now, if it is changing from one energy to another energy, for example, this is initial or final, whatever it is, then we can take change in energy between these two levels will be equal to, we can write 13.6 into a general formula, Ni square minus N final square. Like that we can write, right? Okay. Now, for transition of option A, that is transition from N, which is equal to 2 to 1, we'll get minus 13.6 into 1 by 1 square minus 1 by 2 square, right? 1 by 1 square minus 1 by 2 square, which is given to be just getting the value on solving, we get 10.2 electron volt, right? Similarly, for the transition from 6 to 2, we'll get 13.6 into 1 by 2 square minus 1 by 6 square. For this, we get the value 3.02 electron volt. On comparing these two transitions, obviously transition from 2 to 1 is having more energy than transition from 6 to 2. So correct answer for question number 33 is option A. Question number 34. The radius of Earth is 6,400 kilometer and g is equal to 9.8 meter per second square. If the body placed at the equator has to become weightless, then the Earth should make one complete rotation in dash hours. Okay. Now let us assume this is the Earth whose radius is taken to be 6,400 kilometer, and let us assume a body is there at the equator. Okay. If this has to feel weightlessness, then its weight, that is mg, must be balanced by centrifugal force, that is nothing but m v square r, or m r omega square we can write. Okay. So for weightlessness of a body, for weightlessness of a body, we can write the condition as this told before. That is nothing but m or omega square, which is equal to mg. So we can cancel mm from there. Omega square, which is equal to g by r, where omega, which is equal to root over g by r. Why we need to find out this omega? Because we need to find out the time period, right? So time period formula T, which is equal to 2 pi pi omega, right? 2 pi pi omega. Now, when we substitute this, this becomes, time period becomes 2 pi root over r by g. So after substituting values of 2 pi root over, even the values of r is nothing but, so 6,400 into 10 power 3 divided by the value of g is 9.8. Even for the pi value, if we just give 3.14, so we'll get t, which is equal to, approximately will be equal to 5080 seconds. Then there will be time period which is equal to, when you convert into hours, this will be 1.4 hours. Then answer for question number 34 is option B. Question number 35. A boat is moving with a velocity 3i plus 4j with respect to the ground. The water in the river is moving with a velocity minus 3i minus 4j with respect to the ground. The relative velocity of the boat with respect to water is. See, first, what is given? A boat is moving with the velocity with respect to ground. So, velocity of the boat with respect to ground is taken to be 3i plus 4j. And also, velocity of the water with respect to ground is taken to be minus 3i minus 4j. What do we need to find out? We need to find out relative velocity of the boat, that is velocity of the boat with respect to water we need. That is nothing but VBG minus VWG. So velocity of the boat with respect to ground is nothing but 3i plus 4j minus 3i minus of 4j. So we'll get finally 6i plus 8j meter per second. So correct answer for question number 35 is option D. We'll see in the next video.